So the last thing I'm going to talk about is inductance. And inductance is created every time you have any loop of wire like this. So actually generators actually act as inductors, motors act as inductors, and transformers act as inductors. But what does that mean? So suppose I have current and I put it through this coil. As current flows through this coil, we learned that it's going to create a magnetic field. But what happens when I try and turn off this current? So essentially, I had current, I turned it on, and then I turned it off. What's going to happen is that now no current exists. So now there's not going to be a magnetic field anymore. So slowly the magnetic field is going to die out and then disappear. It's going to get weaker and weaker until there are no more magnetic fields in the loop. But interestingly enough, look, the magnetic field slowly dies out. In other words, the magnetic field is changing. So it changes. What ends up happening then? Well, whenever magnetic fields change, they create current. So although I shut the current off, what ends up happening is now the magnetic field wants to create its own current to sustain itself. So in other words, what ends up happening is although you get this, you might suddenly get a new spike up of current before it slowly dies out again. And you'll actually see this type of thing all the time in electronics, this sort of waveform. You have current and you try and shut it off, it's going to end up spiking back up because this magnetic field doesn't want to go away. In other words, you can sort of think of it like this. The original current that flows through ends up creating a magnetic field and it stores magnetic energy. It's sort of like a battery. It stores energy in the form of a magnetic field. And this magnetic field doesn't want to go away. So it's going to try and create new current and to get rid of all of its energy as it dies out. It's actually very similar to the way a capacitor works. You have a bunch of charges that you build up on one side of the capacitor and it creates an electric field. This electric field essentially stores energy. A capacitor basically stores a bunch of energy in electric fields. And all an inductor is doing is it creates a magnetic field and it stores energy in the form of magnetic energy. And similar to how a capacitor does not like its voltage to change because there's a buildup of charges, and in order to decrease the voltage, these charges are going to have to slowly come off of here. In a similar way, inductors don't like their current to be changed because if the current changes, well, then the magnetic field changes and it tries to protect itself by creating new current that will end up spiking back up.